Okay, so for question number 2, okay, for each of the following scientists describe his invention, the type of the energy the inventor was able to produce, and how it was produced. Okay, so Oersted. Oersted was the guy that had the current carrying wire that produced a magnetic field. All right, so he used electrical energy to produce a magnetic field, which then later led to the development of the electromagnet and the transistor radio, okay, and radio transmitters. Okay. Faraday did the opposite. Okay. Faraday was the one who discovered that a magnet could push electrons through a wire and create an electric current, and he built the first generator. Okay. Seebeck built the first thermocouple, converted heat directly into electricity. Okay. Edison built the first light bulb. Okay, we didn't even kind of go over that part. I kind of skipped over that, but Edison is the light bulb guy. Okay, and Volta built the Volta pile, which converted chemical energy directly into electricity, which was the birth of the battery. Okay. All right, so that actually answers both question 2 and 3. Okay, question number 4, what's the difference between nuclear fission and nuclear fusion? How are they similar? Okay, the difference is what happens to the atom. In fusion, atoms are forced together. In fission, atoms are broken apart. Okay, and how are they similar? Well, they both release the energy stored in the nucleus of the atom. They both require the nucleus of an atom to be altered. Okay. All right, question number 6. What's the modern theory of the source of energy for the sun? Nuclear fusion. Okay, the gravity of the sun is sufficient that it crushes the hydrogen atoms together to form helium. Okay. And as the star ages, it will start fusing helium into other things, and then eventually it gets too difficult and it'll just peter out. Okay? Number 9, describe the contributions the following people made. Okay, Sadi Carnot, we did kind of skipped over him, but he was here with Joule. Okay, he performed experiments in an attempt to transform heat into mechanical energy. It was actually the kind of laid the framework for the internal combustion engine. Okay, so a pretty important contribution. Okay, there. And then we had, so we had Carnot, and then we had Black. Okay, Black was the one who came up with the idea that heat always flows from hot to cold. Okay, and then we had Young. He's back here with the steam engine stuff. Okay, we kind of skipped over him too. Where was he? So here's Joseph Black, and then Benjamin Thompson here. He was Rumford. Okay, he's the one who came up with the whole idea that mechanical energy was related to heat. Okay, and then what was the last one? Oh, sorry, James Young, not Thomas Young. James Young. Oh, I skipped over him. Did I even put that sheet on here? I might have missed that one. Thomas Young. Okay, he was the one that linked mechanical energy to the idea of kinetic and potential. Okay, so he's the one who kind of came up with the idea that mechanical energy, work is a change in mechanical energy. Okay, all right. So definition, capacity to do work. Okay, and then we've got explain how Joule proved that heat could be produced from potential energy. So that was his falling block experiment. He just had to explain that the falling block, work was done to lift the block, and when the block smashed into the other block, the kinetic energy that came from the potential energy turned into thermal energy, which raised the temperature of the block. Okay, looking at number 12. Okay, given the following situations, what's the major form of energy involved? An antacid tablet starts to bubble. Chemical energy. Okay, chemical energy for that one. Fluorescent dial on a wristwatch glows at night. Light energy. Okay, downhill skier begins to ski down the slope with increasing speed. Mechanical energy would be the best answer for that, but I would accept potential or kinetic as well. Okay, a tingling sensation is felt on the tongue when it is touched to the terminals of a 9-volt battery. Okay, that would be electrical energy. Anyone ever test a battery that way? Yeah. Not many people even use 9-volt batteries. They're basically just for smoke detectors these days. But that's how we used to test them back in the day. If you got a little shock, then it was still good. Okay. The inside of a car gets extremely warm if the car is left in the sunshine. I'd accept light or thermal energy for that one. A seagull lifts a clam high above the beach. Mechanical energy would probably be the best, but I'd accept potential as well. Compass needle held over the surface of the earth points north, magnetic. Okay. And then for number 13, describe an appliance or machine that for its operation requires the following forms of energy. Chemical, anything that burns fuel. Okay. Light, so anything solar powered. Okay. So your calculator, if it's got solar panels on it. Okay. Heat, thermocouple, okay, would require heat. Electrical, anything you plug into the wall would be acceptable as an answer there, anything that runs on batteries. And then magnetic, electromagnet would require electricity, so a radio requires magnets, okay? Electric motor requires magnets. Okay. For 14, describe an appliance or machine that produces the following forms of energy as it operates. So what's something that produces chemical energy? It's actually a tricky one. An oil refinery would produce chemical energy. And this isn't a machine or appliance, but a plant does. Plants produce chemical energy from photosynthesis. Okay, something that produces light, a light bulb. Seems like a pretty straightforward one. Okay, thermal energy, a heater, a toaster, your curling iron, your hair dryer. Okay, electrical energy, a generator, a solar panel. Okay, magnetic energy, an electromagnet. Okay, a radio. All right, questions on those? Okay.